Can you guys hear me all right? Everything's good? Cool. Well, happy end of the conference. Thank you for joining me in the last session, and hope you guys are ready to do some Kotlin work for all you C# devs, and enjoy my corny, just half-hearted Photoshop of Super Smash Bros. Melee's versus sign. Really, though, we're not going to be doing like a Kotlin versus C#. We're going to just be sort of comparing the languages and allowing you to basically take your tools from C# and your knowledge of C# and writing applications in that style and apply it to Kotlin. So real quick, for those who don't know me, I'm Alex Dunn. You'll find me online as Suave Pirate. That's because my name is super, super basic. When I was trying to basically start actually building my online personality, I was like, oh, let's see what kind of Alex Dunns there are. Turns out there's 3 Alex Dunn developers at Microsoft, so I didn't really have a good place to sit. So I wrote a little name generator, took a bunch of stuff from the dictionary, just adjective and noun, and here I am as Suave Pirate, and I couldn't even get the full Twitter handle. So my blog is alexdunn.org or suavepirate.com. This whole series is also a blog series on alexdunn.org, and it's also shown in a bit of content in Pluralsight. So I'm a Microsoft MVP in the .NET space and Azure space, and also a Pluralsight author where my courses focus in Kotlin, and specifically Kotlin and Android. So I have getting started courses. If you do like the Pluralsight Skill IQ exams for Android or for Kotlin, that's a lot of my questions, and I'm sorry if they're hard or super easy. But you can kind of see like that sort of weird balance and turmoil I have internally has led to a super interesting talk like this. I don't know if I can follow up very well from the last talk, which was like building tanks in Unity and blowing shit up, but we can compare languages and that'll be pretty cool. So to preface, like I said, I don't want this to be a let's ditch C# and go to Kotlin because Kotlin's so sick. And I also don't want it to be like, look, I showed you guys Kotlin and this thing actually sucks, we should stay with C#. Instead, I think both really have a place, and I think that they come across as so similar that it makes sense to take your knowledge from either one and apply it towards developing something in the other if you have that need. And we'll get into basically some code compare and contrasting, looking into syntax for Kotlin versus C# for some of the basics, and then get a little more complicated. And then also talk about like those use cases in terms of like what platforms they best fit and when you should use each one. And lastly, we're specifically talking about Kotlin 1.3. I just updated this talk to do 1.3 and also some C# 8. Both of those releases between C# 8 and Kotlin 1.3 were like massive releases. So Kotlin 1.3, we get things like better asynchronous programming with coroutines, and C# 8, if you saw any of like Matt's talks or John Skeet talking about some of the new features, it's ridiculous, like nullable reference types, default interface implementations, asynchronous streams, and we'll talk about all of those and also compare those new features and how even still they're continuing to sort of lift each other in terms of like features that the language can complete. So I'll just do a quick overview of Kotlin. How many of you guys actually know what Kotlin is and you walked in here knowing you're going to learn a new programming language and not like a framework? All right, how many of you guys had no idea what Kotlin is and you're like, oh, another thing for C# developers? And yeah, sorry. We're going to talk about an entirely new programming language that has nothing to do with C# other than that they're really similar. So the brief overview of Kotlin, it's an open source, statically typed language, and it's written by JetBrains, one of the gracious sponsors of this conference. It supports mostly, and it's sort of targeted towards mostly an object-oriented style programming, but there is a lot of support for functional programming in Kotlin. We'll talk a little bit about that, but not that much since, again, this is like a C# for Kotlin, and it runs on the Java virtual machine. That's not just like I can execute like a Kotlin like DEX or custom DEX or something. It's 100% interoperable with Java, which means you can write things in a modern language, throw Java behind where it belongs, and actually use usable code, but still like retrofit it in the Java, and then the other way around, take existing Java libraries, use them in your Kotlin code the way you'd sort of expect. And I think this last line is the most surprising, right? As we talked about, it runs on the JVM. You can actually compile this thing to JavaScript, and that's like an officially supported compiler. We won't get into too much depth about how that works. I have like a totally different talk and series on that. But basically, you can take like TypeScript types, run it through a tool that they have and generate Kotlin types, and then compile your own Kotlin into JavaScript and then just load it all up as one like minified file. So it's pretty cool. The primary goals of Kotlin as a language, I think, are really important because you'll notice as we go through the code that every single bit of code we look at keeps all of these things in mind. So number one is reduce verbosity. Coming from like the Java world, which is Kotlin's sort of roots, Java is super verbose. I hate Java personally. Like it sort of stemmed into C#'s development sort of code style. That was very intentional from like C#'s like J++, and now we actually have a real programming language. But also to support many different styles of programming. So like I said, there's object-oriented, there's every tool you need for that, and we'll dig into that. But also functional, you can write things procedural, you can script with it, and sort of everything in between. And then from the beginning, having backwards compatibility. It's super important for being able to execute Kotlin in older Java code. So even though we're sort of introducing like modern language features, we still need to be able to find some way to make that usable in our ugly Java. And then, of course, the faster development cycle. Like I said, this comes from JetBrains, and their entire team, everything they do is about making our lives easier with building code faster and building our applications faster. So you'll see that in sort of like the ability to do like multi-platform deployments with Kotlin, just how easy it is to quickly spin up Kotlin, and just how integrated it is into the different IDEs. So in psychology, there's this sort of concept called speech convergence. And it's essentially when someone is thrown into a room with a bunch of people who either speak a different language or speak with an accent, they start to sort of fall into that bucket as well. I personally have it so badly where like if any of you come and talk to me afterwards, I'm like fighting internally not to like speak with a bad British accent. And it will slip sometimes, and so I apologize, I'm not mocking you. My brain is just wired in the worst way. But this concept also comes through a lot with new programming languages. You can tell what's inspiring a language based on its structure, its platforms, and its use cases. And Kotlin themselves explicitly say on their website that it's inspired by existing languages like Java, obviously. They just want to get rid of Java, good call. C#, which is why I get to talk like this. JavaScript, because it can run in JavaScript, and then Scala and Groovy, those sort of more functional and procedural languages. So any questions about like Kotlin at all? And what I'm going to do next is get into like some of the very basics side-by-sides between like a C# example and a Kotlin example. And basically, I'm going to break this down so you guys can just ask questions the whole way. Like, feel free to interrupt me. Cool. So let's start with a POCO, plain old CLR object. Pojo if you're in Java, and what I've seen tossed around sometimes with a POCO with a K for Kotlin. So I'm very much into dogs, and especially rescuing dogs. So all my examples are going to be related to that. So just don't be surprised with how many times you see dog or a service that relates to a dog or something like that. So here we have a C#7 version of a POCO for a dog that has a name, an age, just an integer, and a breed. It's as simple as we can get it, right? So in the Kotlin world, we have the exact same sort of structure, and I'm going to start by pointing out some of the differences here, right? So you'll notice right away everything is explicitly nullable or non-nullable, reference types, value types, or whatever. That is super similar to the C#8 version of nullable reference types with that optional field you can turn on now, and we'll talk more about that in a bit. But you'll also notice that we have to explicitly set a value for these properties, whereas in C# we get that sort of default concept, and we can even call default in terms of assigning a value. So for string name and the C# side, that's just going to be null by default. Int will be 0, breed will be null as well. But in the Kotlin side, all three of these are nullable. We have to explicitly set it to null or to a value. And then we can take a look at some constructor overrides. So in a basic POCO, we don't have to define our default constructor, right? It's there. We have our empty parameters constructor, but if we want to add one that adds the ability to set the name, age, and breed directly from the constructor, we have to now add the default and then add any overrides. Same thing in Kotlin, except you'll notice the syntax is a bit different. And one thing you might have noticed right away is that up here in the signature is where we actually define our default constructor. So sort of staying in that mindset of reducing verbosity. Let's just throw it up there. So then we override constructors with just adding that sort of constructor keyword, whatever parameters, and then whatever logic we need to do. Kotlin also introduced this concept of a data class. It's kind of similar to using a struct instead of a class in C#, but actually does a bit more. So this one-liner at the top is actually the entire class definition with a constructor that takes in those values. But instead of saying, like if I go back to the previous slide, just name is a string, age is an int, or whatever, we actually say val name is a string, val age is an int, and val breed is a string. And that actually gives us those public accessible properties with those names as well as the constructor to set them. It's one line, no braces. You can do that with any other class, but I specifically want to talk about the data class because you can instantiate it like this. You get default copies for helping with immutability. You get equality comparisons. You get like hash code sets and stuff like that too, all just built in by just slapping a data on it. There's also this concept of val and var. In terms of relating that, you can think of var as a variable and val is a value. So a variable can change its value. A value cannot. It's set once and that's it. If you relate that to C#, that'd be like a constant in a property or a read-only because you can set them in the constructor and you're good to go. The difference, though, is actually in this function here, where val and var is actually true for any statement of a value or a variable, regardless of scope. So here we're not defining properties of the function bark. We're just saying like a local variable, and we cannot set the new value of sound because it's a value. We also have that same sort of concept of getters and setters. If you've ever come from the Java world, this isn't a thing. You have to explicitly have like a get property name and a set property name, and that's sort of how you handle encapsulation. Again, the idea of saying, throw away all this extra methods and functions we have to write. Let's just use our getters and setters. C# has done this from years ago, but we have the ability to call a single get on this age, and it does a calculation, and you can just call .age. In Kotlin, we have almost the exact same thing. We can define get as a function, and it returns a whole bunch of calculations, except we have to do more because we're using Java's date, and it's garbage compared to C# date time. But everything else is sort of the same. You have the same sort of like initial sets on the right and all that. And then if you're doing a set method, same thing, you should have next line, set, whatever you need to do. When defining methods and functions, in C#, we have the ability to have a void method. It doesn't return anything, it just executes some code. And we can also have return types for methods, right? In Kotlin, it's the exact same concept, except everything's just prefixed with function. That's how we're telling it that this is a function or a method. And then the return type, just like everything else, is over here on the right side. After that, it's just like executing any other method. We can just call dog-adoption service.adopt. One thing you'll also notice is that we don't have to use the new keyword. If we take the class name and we throw the parentheses around it, that's how we're instantiating it. Just taking little shortcuts to cut up some of the extra characters we got to type. My favorite thing in C# that I abuse the hell out of, especially when writing new C# 8, is null, coalescing, and propagation. So in this case, we have both examples in one. We have this breed class. It has a nullable integer. And then in the dog class, we have that breed, which is a reference type, so it's default nullable. And then we also have the ability to get that with the propagation rather, and the coalescing. So propagation, let me see if I can get this to work. Ooh, there we go. Propagation being that if breed is null, this whole statement is evaluated to null, where coalescing is saying if the left side is null, then return the right side. If not, just return the actual value of the left side. And if we want to do that and we're saying, hey, I actually know that this isn't going to be null, don't worry about it, we can just do it dangerously and risk the null reference exception, and then also call .value on those nullable types. That does change a bit in C# 8 where you start throwing the bangs or exclamation points, whatever you want to call it around. Kotlin has both of those as well. It's just a slight syntactical difference where we still get the propagation with the question mark and the dot, but with coalescing we get the question mark and the colon. And then if we're going to do something dangerously, we have to explicitly put the double bang. It's also just a good tell, like I'm probably messing something up here if I have to do this, especially because everything's nullable or not nullable. So if I'm saying, I guarantee you this nullable type is not null, I better know what I'm doing, and I can see that I can with tons of exclamation points everywhere. So questions on the basic syntax of that, and then we'll take a break from the sort of side-by-side code examples, and we'll talk about the platforms that both of these support. Yeah?
Kotlin has no access modifiers, no public.
We'll get into that. I'm going to talk a little bit about the encapsulation, but the default for Kotlin is actually public. So if you want it to be non-public, then you got to throw a private or protected or internal on it. Yeah. Any other questions? Yeah.
Is everything inherent from object?
Sorry?
Is everything inherent from object?
It does, yeah. So other than functions, it's unlike like a JavaScript object function. Those two are separate, but you can still actually execute that. So everything comes from object, yeah. And you'll actually see a really cool indicator they have for that when we talk about statics. Anything else? Cool. All right, let's talk about some platforms. So these are more or less my opinions. We as C# developers know that C# can run just about everywhere. But we sort of have like these buckets of what most people are using C# for based off even just like Stack Overflow surveys. So obviously ASP.NET, ASP.NET Core, we're writing web applications, we're running things on IIS, we're running things in containers, we're using ASP.NET. We also have cloud apps, and that's sort of just like a generalization of where we're running our C# code. So that could be running like a function, a Lambda, in terms of like Azure Functions, AWS Lambda, or just any sort of cloud execution or services. We also have the entire Windows platform, so think UWP, WPF, WinForms. And I like to consider Xamarin one of the newer primary platforms. I myself abuse Xamarin a lot, sort of how I came into the Microsoft MVP stuff was always through Xamarin. And so we can build cross-platform mobile apps on that platform too, which runs on Mono. Kotlin's core has Spring and Ktor, so think of this as their ASP.NET, right? Spring is Java's MVC framework. It's what allows us to write Java code that runs in the JVM and can take in requests and do everything in between. And the Kotlin team actually introduced and runs this open source project called Ktor, which I still don't know if I'm saying right at first. It's just supposed to be called Ktor, but I'm going to keep going with Ktor. So it's mostly like an even nicer version of Spring MVC. It runs more similarly to like an ASP.NET MVC or Node with Express, where you're defining endpoints and routes, and you're just running your code from there, and you can handle all your abstraction layer and all that. We also have the same thing with cloud apps. I think this is actually a more popular language to use for cloud apps simply because of the JVM. So obviously, Amazon, if you don't know, does a lot in Java. So a lot of things on AWS start with their Java SDK first, then their JavaScript SDK, and then someone finally supports a C# developers. And then Android, which I think it was about 2 years ago that Google officially announced Kotlin as a supported language for Android development. So outside of just saying like, oh yeah, you can write Kotlin and compile it with your Java stuff, and now you've got Android, their tooling with Android Studio is actually pretty incredible. So you can do things like take existing Java code, like an entire file, just like right-click, convert to Kotlin, and it's done. So nice. Or the other side, like take an existing Java snippet, copy and paste it into a Kotlin file, and it'll go, hey, I think that was Java. You probably want to switch this to Kotlin because you're a smart person. Do you want to do that? Yes, and it dumps it in for you, automatically translated. And it's like really well done too. It's not like translating as a bunch of build errors. Because they're interoperable, there's like, oh yeah, we know like static is companion and these objects go to this, and get rid of the get sets and stuff like that. In terms of other platforms though, C# covers a whole lot, right? So we have new IoT services, even more coming out with things like Meta Labs' new microcontroller and stuff like that. We have Unity, which if you were in the room here before, we got to saw a great demo of stuff blowing up in Unity. We have Mono, which like I said is also the foundation of Xamarin, but is also used to run things on any sort of Nix kernel. And then Uno, a newer cross-platform mobile, and then Blazor, which if you didn't have a chance to see those all the different Blazor talks at this conference, I definitely recommend finding the videos later because Blazor's pretty sick. Kotlin's other platforms include iOS, actually, and this is sort of like a secondary platform where people are like, hey, we can now compile the native. Let's see if we can like translate things from iOS to Kotlin. So like if you go to Kotlin Conference, their iOS app's written entirely in Kotlin, which is pretty cool. JavaScript, like I said, compiling down to JavaScript, that's still in beta. Native with LLVM, that compiler to native is also in beta, but they're working on releasing that in production. And then anything on the JVM, which Java always boasts. We have 100 billion devices that run Java, or 300 billion devices now, whatever it is. Anywhere you're doing that, you can also use Kotlin instead. Like I said, let's just please get rid of Java. So I sort of have this Venn diagram where on the left with C#, we have the Windows platform, right? That's what we can build for in a very native way that we can't really do with Kotlin. And Kotlin everywhere that the JVM is running, I don't think I'd ever dare trying to compile C# to the JVM. But like literally everything else, both of these platforms can, or both these languages can support in one way or another. Kotlin is still very immature. It's only in a version 1.3. So where C# is moving into 8 and it's been around for so many years, Kotlin's still sort of in infancy. But I expect as this community grows around just the love for the language itself, we'll also see more of the platform support as well. Any questions about that before I get more codey? Cool, I actually expected more questions for that because people are like, but what about this framework and this platform? All right, let's talk about object-oriented programming. So for those of you who have written C#, and I hope most of you here are, because that's kind of the talk, object-oriented programming is sort of the foundation of our design patterns and stuff. C#'s introduced some features to make it a little easier to not do object-oriented programming, which some people hate, some people don't. But let's start with the foundation, right? We have a class that defines an object, and we start with our object. And we need to make sure that Kotlin can help us fill out the other pillars of object-oriented programming. Now, whether you want to debate if it's this for abstraction, encapsulation, polymorphism, or inheritance, or if you don't like the idea of inheritance being its own, because polymorphism can arguably handle that, or if you've got like the full 6, I'm talking about these 4. And in my opinion, the things that we need to have in order to support these are encapsulation keywords, public, private, protected, all that. Inheritance is obvious to be able to inherit classes. Abstraction and polymorphism can also be helped with the way that we can handle multi-level inheritance or interfaces and abstract classes and sort of everything in between. So let's start with interfaces, which is my favorite, recently debated for some reason, thing in C#, where people are like, interfaces are abused and DI is too much. I say, no, I love DI. So we have an iAdoption service, right? And we have 2 methods defined there. We have a void adopt dog and a void adopt dogs that takes in a list. And we have our implementation of that, which is dog adoption service, which implements iAdoption service and does some super basic stuff. We can loop over and call the other adopt dog. In Kotlin, we do get our default interface implementations. So something that's new in C# 8 is being able to do that, but I'm also using the actual like Java naming convention. So an interface is the dog adoption service, and the class is the dog adoption service implementation. I hate this naming convention. I like the I better. It's shorter. It's easier to read. Where I'm like, dog adoption service, is that a class or an interface? I have no idea, because what if it's a class that doesn't implement an interface and it doesn't start with or end in frickin' impl? Sorry. Anyway, we have this adopt dogs, which goes around each of the dogs passed in and calls adopt dog, and then here all we have to do is implement the one method. Encapsulation, we talked about this a little bit, where everything is sort of default public in Kotlin, where that's not true for C#. So we have some common keywords like public for classes, and then for any members of that class, we can also encapsulate it with certain keywords like public, protected, private, or default, which is like basically private with like some other extra gunk. And then within that, we can also nest classes, right? In Kotlin, we have all of the same ones, but there's also a little bit more. One thing you'll notice right away is that all of a sudden we've got this open keyword in front of our class. Because just like everything is default public, it's also default final, which if you're not familiar from the Java world, it's essentially saying that it's default public sealed class in C#. So in order to say that something can inherit from dog, we throw the open keyword. And then if you, for whatever reason, need to explicitly say that it's not inheritable, you can throw final up there as well. Same thing with public. It is a keyword you can use, but it's default, so no one really does that. So you can keep everything on the left side, like all on a line. So then we have our default public and final variable that can change, name, our private variable of breed, our protected, which is similar to C#'s protected, but I believe it can actually be accessed within the entire same package, which is essentially a folder. And then we have private for those sort of subclasses as well. We have a whole bunch of other keywords we can use, though. C# we can use sealed, which is, like I said, is sort of similar to the default for Kotlin. We have virtual, which explicitly says this can be overridden for a method or a property. We have internal, which means that only my final package, only my final DLL can access this, nothing else. And we have our default. And in Kotlin, we have final. Like I mentioned, that's making sure that it's the same as sealed, but can also be applied to local variables. So that's like val is the same as a final whatever type in Java. And then we have open, means it can be inherited. Internal, like I mentioned, and then external, which I personally haven't found a use case for, but it's basically like only people outside this can access it. I don't know why you'd really do that, but you can. All right. Let's carry on. So we have abstract classes. This example isn't the greatest because it's basically like an interface with a default implementation, but with an abstract class, we can add the keyword abstract, and then within that, add abstract to any of our given members. So that means that any implementer, or inheritor, sorry, of that abstract class needs to implement that abstract member, right? So that's like having an interface where we have a default adopt dogs. The biggest difference is if you haven't used abstract classes is that you can also use things like protected and stuff like that. If it's abstract, it doesn't have to default public. And you can also only inherit one thing. And that's also true for Kotlin, where we have our abstract keyword. It's an abstract final public class, an abstract public function adopt pet, and then the loop that sort of runs over it, which is then implemented to call the abstract method. And our inheritor, our child class of adoption service being dog adoption service, has to override that adopt pet. Now for the not so object-oriented things that people usually try to avoid side of it, the concept of statics and stuff like that, right? So to make something static in C#, we just throw static keywords in front of it, and now it can be accessed in a static way. We can just say adoption helper.adopt pet, and we're good to go. But in Kotlin, they actually use a naming convention that I didn't expect. So there is no static keyword in Kotlin, which really threw me off when I was like first learning, and I was like, oh, how do I make like an extension method and make it static? And they're like, nah, you don't do that. So it actually has the concept of an object. Which if you think about it, makes sense, right? A static class is an object that's initialized when the program's run initially. And so instead of saying a static class, we just have an object, and then we define whatever members of that object we want, and those are all brought up statically throughout the application. So the same thing in terms of how do we actually use this adoption helper, it's still just adoption helper.adopt pet. So on top of static objects, we also have the concept of static members. Normally this is like, all right, yeah, I get it, we throw static around in C#. But I wanted to show this to show you the real difference in Kotlin. So in this case, we have a public non-static class of adoption service, and we have the instance method of adopt and also a static one that takes in that pet as well. And the use of it, or instantiation of it, is we have to instantiate adoption service versus not for calling static, right? That makes sense. Everyone knows how to do that. In Kotlin, like I said, there is no static keyword. So we have our instance adopt, we have our non-object, just an actual class of adoption service, but then we have this concept of a companion object. So like I said, things that are static are objects that are initialized, and so when you create a companion object, what you're doing is saying, take this object and everything that can just run by itself and just marry that with the class that holds it. So in the end, you still end up executing it the same way, where you can say adoption service.static adopt. But the biggest difference is that when you actually try to execute this in something like Java or in JavaScript, you can't just say adoption service.static adopt. Instead, you say adoption service.companion.static adopt. So it ends up adding an actual like static property or object within the class itself. So I know it's kind of funky. Does anyone have any questions on that? Yeah.
If you're on classes and objects, does the static member need to be a companion object, or can it just be a function?
If your class is static, so if you just had an object instead of a class, I don't think objects get sub-companion objects. I think it's just classes, abstract classes, and I don't think interfaces do either. So, yeah. Any other questions on it? Cool. So let's talk about what I feel like most people end up using statics for nowadays and build extension methods. I see people abuse this all the time. I personally do it a lot because it's super cool to be able to just say like, oh, dog.adopt. Now it looks like I wrote good code because no one will see that I just wrote a shitty extension method. I'm not knocking anyone who uses extension methods. I really do it all the time. I think they're super cool. But in this case, we have to wrap in C# our extension methods in its own class, usually named with our postfix with extensions. And then every method within that has to be static. And if you add your parameter and you add the this keyword to the first parameter, now we know the subject of that extension, right? So now we know that an adoptable dog should be able to call adopt, and we can reference the dog anywhere in that method and call whatever we want on it. Kotlin simplifies this a lot. This is another thing in Kotlin that I really do like a lot more than how it's implemented in C#. So same concept, we have an adoption service, and it has a function that calls adopt, and it calls that extension method. But what we do to create an extension function is we take the type, and this is done in global scope or within any other scope. So you can scope your extension methods, which is really cool. But you just say function adoptable pet, the type, and then you define the function right afterwards. So for example, if I only wanted this extension function to be available within this adoption service, I just lift this bit, throw it within that class, and now I can't access it anywhere else. But instead, I've gone ahead and put it at the global level, so anyone that's referencing my package can execute that. We can talk a little bit more about global scope later on when we talk about sort of the C# 8 stuff, but it's a bit of the side that gets into like how you can execute something functionally. You don't have to have a class. You can just throw functions wherever you want and import it and then pipe, pipe, pipe. So some other things that are Kotlin only, you can actually add extension properties. I know we've talked a bit about doing this in C#, but it works very similarly to how you would define a function, but instead of that, if I go back, having function adoptable pet.adopt, we just say val adoptable pet.name to find the type, and then we have to have explicit getters or setters. So we can't just end it there and just say, yep, now it's got a property called name that's a string. But you can actually use getters and setters, use some other scope, more like a Java style where you're setting some other field or something like that. We also have the ability, and this is another thing I don't think I'll ever find a use case for, but you can add extensions to your companion object as well. So that, like I was saying, how in Java style you have to call .companion. This is like the same sort of thing here, but you're basically saying, take my companion object of my class and also give it this extension. I guess like a use case for that would be if you already have yours defined or someone else does, but you want to give it another static thing instead of having like some sort of helper method, you can do that. I just haven't really run into it yet myself. So any questions on that before we get into sort of the cooler typing sides? And I'm just going to keep chugging water because my mouth gets so dry. Cool. So both these languages have some really cool typing features. Not in the sense of a keyboard typing, I mean like an actual class typing and stuff like that. In C#, we were introduced to the concept of a dynamic type, probably the most hated type the world has ever seen. Those of you who write C# all the time probably forget that you can even do this, but instead of having a strong type, you just throw dynamic, and then the type checker and compiler just go, oh, I don't know, I trust you. I hope that this pet thing has an is adopted field. But if it doesn't, then the whole thing blows up at runtime, and you also get some very vague errors, and it kind of yells at you for being like, stupid, shouldn't have used a dynamic type. We also get a dynamic type in Kotlin, but the funny thing is it doesn't exist in the JVM. So if you're compiling against the JVM for something like Android or Ktor, you'll never be able to do this. You won't be able to build. It'll yell at you. But if you're compiling to native or to JavaScript, you can, mostly because JavaScript, everything's a dynamic type. They don't really care. It's like saying in TypeScript, like just type this as any. I don't care what it is. But the reason why they can't get in the JVM is because of that backwards compatibility focus. So in order to support sort of the older legacy versions of Java that are or really any version of Java that's so tightly bound to its type system and its definitions, there's no way they can build any sort of dynamic or expando object or anything like that. But if you are compiling against anything else, feel free to also write this bad code. We also have type inference. This is something that's becoming more popular in most languages, especially new languages. It's something that was created because we realize as people, we don't need to always say what it is. Like we can infer that P here is an adoptable dog because I know that the pet exist method takes in a function that uses an adoptable pet. So I don't have to go and say adoptable pet P arrow function, ID equals ID. But that is where the inference is happening here. Same thing in Kotlin, it's really similar. And there's a few other places that inference exists in both of these languages, but I figured it was good to sort of show those side-by-sides here. So on the left side, we define an expression of a func of an adoptable pet to return a bool. We just pass that into the link.any method. Probably doesn't need to be an expression, honestly. I just kind of wasted space with that now that I think about it. It could have just been a func, but anyway. And then on the right side in Kotlin, we define a predicate as the arrow function. So this is the type, right? This is saying predicate is a function that returns me a Boolean given an adoptable pet. And we also get that sort of any feature. If you've ever tried to write Java lately, you don't get any of this cool like array management stuff where we basically get link in Kotlin, but we won't get into all that sort of library stuff. And then at the top, we can say pet exists. We use an arrow function. Some slight syntactical differences. There's actually reasons behind it. So we can't actually create a function as an object and pass it around in Kotlin simply because Java is not cool with that. So instead what we do is we basically like say pet exists is a function and it takes this function and we're just executing that function within it. That's something that I think C# just handles a little bit better, but the way to get around it is pretty clever. If you're passing around a predicate or something like that, you just have to use the curly braces. Any questions on any of the type inference or anything like that? And I'll get into generics. Cool. So generics, One of my favorite things in sort of the object-oriented programming world, but especially in the type inference world, where now we don't have to build implementations of so many classes depending on what types we build. We can build like generic stuff that can do a whole bunch of things. And C#, when they implemented generics, sort of became like the leader in terms of like, this is how generics really should be. Because all of us love using generics in C# because we can do things like say, I can take type T, but that type T better be an adoptable pet. And because of that, I can now call those methods or properties like isAdopted because I know that exists on my adoptable pet. Other languages like Java's initial implementation without that is just, it almost makes generics useless or at least confusing in order to build something like in-depth or usable. Kotlin started with generics with that in mind, again, just coming from that background of C#, like this works, but I don't like the fact that I have to say where and put T two places, so instead we define it right here at the top, right? We say pet adoption service of type T, and type T better be an adoptable pet of some kind, and then we get the same sort of autocomplete. We get the ability to compile this in any way we want and use the isAdopted without running into any errors because we can safely infer the type. So I also want to talk a bit about tuples. This is something that I also see debated quite a bit in the object-oriented world because it's kind of just a shortcut to avoid making like another class. Just pass in this type that is these other two types or 3 or 4 end types. So for those of you who don't use tuples or when C#7 introduced them, I was like, I don't care about that. It's essentially the idea of creating a type that contains multiple other types. So in this case, we have this dog and shelter as a type, but those are also 2 classes below. And then the way that we access each of those different types within that is we can say item 1, and now we know that's the dog, versus saying item 2 or item 3 and stuff like that, but we can also give them explicit names. So I can say dog, and the name of it is pet, and then I can say data.pet rather than item 1. But if we don't, at least they give us something to access it. You can also access it with sort of like the array accessors and stuff like that. Same sort of functionality in Kotlin, displayed a little differently with a little bit of helper tools as well. So we have the idea of tuples. We have a tuple type. We just basically throw in a bunch of generics n number of times. I think it's actually limited to like 20 or 16 or something like that, but I hope you don't have to run into that. But they also give us 2 different shortcut types for tuples. So we have pair, where we have 2 different types, which is what we're using here, and then also triple, which is just 3 different types. So instead of having to say tuple everywhere and pass it around, you get 2 types, and that's how we're able to get .first, .second, and .third for those other types. If you go beyond that, you got to use accessors or explicit naming to pull out those properties. So in this case, it's the same thing. We're passing in a pair of type dog and shelter, and we can say data.first.isAdopted is true. Questions on any of the type stuff? I know it's sort of like, it's a very debated area in both programming languages because it's like object-oriented stuff, but then not so object-oriented. Yeah?
In generics, can you say it must be like an email or a primitive?
Yeah, you can. Just like in C# where you can say like, oh, this has to be a class, or this has to be a class with this constructor that takes in these things, or a class with an empty constructor. You can do those same sort of things in Kotlin. Yeah. Any other questions? Cool. So my, I think, favorite part of modern programming in asynchronous programming, especially coming from a mobile developer and voice developer background, asynchronous stuff is extremely important. To be able to take something, an action that happens on the UI, go execute something in the background while also letting the user do something, but still handle the result when it comes back is so invaluable. And having to do that before Kotlin in Java was a nightmare. And also just in C# before we were introduced to async await. So let's take a look at that here. C# manages most of its asynchronous programming with the concept of async await in tasks. So we have an empty task that means it doesn't expect a return type. Now we can say that's async. You can also use async void, but obviously you're going to get warnings that are like, it should be a task, otherwise you're not really thread safe. And then we can await another asynchronous task method. We can also run these in other tasks.runs. We can batch these asynchronous tasks together and await all of them. A whole bunch of stuff that makes our lives easier to say, like, go do this thing, and then like when you get back, do something else, and I'll just carry on over here if you're doing it right. Kotlin introduced this concept in 1.3, and this is I just recently updated these slides for this as well, called coroutines. So before coroutines, you had to use other libraries that basically used a whole bunch of callback methods and everything else from sort of the traditional asynchronous programming, similar to more like a promise type system like JavaScript has. But in this case now we have coroutines, and coroutines are amazing, and they're a very different approach than other programming languages take. What we have is the ability to use either a global scope or a custom defined scope and then execute coroutines. And so the idea is that we have a global dispatcher or a custom defined dispatcher that's going to go execute these tasks and send them along, but then we can do all sorts of things with that task while it's executing, including like just waiting for it to come back, executing other coroutines, throwing that on other dispatchers, waiting for a whole bunch to come back. Similar functionality that we get in C# with async await and tasks, but we do get it in sort of like this new style that almost feels like I can actually control this without saying, like, if I just run task.run on an async await or a C# task rather, I'm going to end up risking like exceptions blowing up and stuff like that, where this keeps a lot of context and you can provide your own context as well in a much more, I guess, like familiar way. So we can look at like a more real world example, real world-ish, obviously this doesn't do anything, where we have this background get. We have a list of dogs there, and basically we want to set that list of dogs in the background. This is bad code. Don't actually write stuff like this. Is not really thread safe. That like the dogs are going to be disposed, and then you're going to lose a whole bunch of stuff. But just bear with me as I go over the concept. So we have a list of dogs, and we want to go get them in the background while everything else executes below it. So we call a task.run and await up here. Up top, we have a task that returns a list of dogs, and it's basically making like a very basic HTTP get as a string request expecting some JSON. And then we deserialize it with JSON.NET. So what's going to happen is that we call background get, we initiate our list of dogs as null, we execute the task.run, and everything else below that just keeps going. In that task.run now, we go await that, and we set the dogs to the result. But like I said, this really shouldn't actually work because everything after background get, unless it has something to keep its context and keep it out of the garbage collector, is going to get booted. We can do this same sort of thing in Kotlin with coroutines. So we have this get adoptable dogs. This get adoptable dogs does not execute a coroutine. It's basically synchronously going and making this request. Other side note, don't just call url.retext, but I needed to fit it all on one screen, so it's nice and pretty. Really, you should probably use a better library. But anyway, we take that JSON that we get synchronously, waiting for it to read everything on that thread that it's executing on, and then we do the same sort of deserialization using Google's JSON library. With that, we actually can execute the get adoptable dogs in background. And so same deal, we instantiate a local variable of list of dogs that's null, and then we call the global scope and launch a new coroutine from the global dispatcher and set that as get adoptable dogs. So what's going to actually happen is we execute it, instantiate it, the coroutine fires, and we just basically continue on. But we can also await a coroutine, and there's a few different ways you can do that. So this is the exact same code, except if we wanted to, for example, do like an actual await the coroutine to get me the results, then we can call .join. And that basically says take the task that's running in this coroutine and bring it back to the thread where I executed it from, or at least in the thread that I'm calling .join in. So in this case, it's obviously the most basic example, but you can actually take coroutines that are in like many different threads and join them into like other threads in completely different areas and sort of give it new context and stuff like that, which I think is pretty wild, and I don't think it's something you can do very easily in C#. So from there, we can talk about tooling, but if you have any questions about any of the asynchronous stuff, let me know. Cool. So in C#, we have some of the best developer tools. I think you guys, if you have to go and write JavaScript code or something, you come back to C#, you're like, oh my God, yes, I can actually like do things quickly and just like control period and tab around and do everything I want the way I want, and everything's fast. At least that's how I normally feel. We have things like Visual Studio, which is now have an even newer focus in terms of like building better developer tools. We have AI in our IntelliSense. We have things that predict the way that we personally use the editor to make it easier to like, hey, I know you name parameters like this, so let me just auto-suggest that, and you can just tab your way through it, and it's like you're not even writing code anymore. We have VS Code, this slimmed down version. You can install some C# plugins and carry on the way you would expect. And then we can also now write it on the Mac. Outside of the Visual Studio line of tools, there's also been this sort of new player named Rider. This is from JetBrains. If you haven't used it before, it's incredible. How many of you guys use ReSharper at all in your Visual Studio? Yeah, I thought it'd be a lot. Imagine just ReSharper as an IDE with like everything else IntelliJ has been writing the entire time. The only difference is that it's not free because it's all part of the JetBrains package. I personally love Rider a lot. I mostly use Visual Studio just for consistency's sake between like my Mac and my Windows machine. but Rider does actually run on all platforms, including Linux, Mac, and Windows, and it's the exact same interface like you'd expect, where if you've used Visual Studio for Mac, it's more Mac-y, it's a little different. You sort of got to get used to setting things up a little differently, or just like force yourself into using the command key as a control key and like try to keep the same shortcuts, which I personally just can't execute well. On the Kotlin side, we have a similar set of awesome tools. So we have IntelliJ, the OG of Java environments that were actually decent, separate from Eclipse, which if you still have to use Eclipse, I'm really sorry. It hasn't gotten much better. IntelliJ, just like Rider or using ReSharper, you're going to get the same feel. And then we have Android Studio for Android development. This is basically Google partnering with JetBrains and saying, like, hey, I like what you guys are doing. Let us just put a whole bunch of Android stuff on top of that. But it's really the same sort of actual IntelliSense, same sort of code management, with a whole bunch of stuff to like auto-generate some Android stuff. But in terms of Kotlin support, IntelliJ and Android Studio operate in the exact same way. You can do that whole like copy Java over to Kotlin like I mentioned. And then Eclipse, they've built a plugin for you, so you can still suffer it with Kotlin. So tooling aside, anyone have any questions? I'm not going to be able to have time to do like any demos of the IDEs or anything like that. So if you have questions about like how that sort of stuff works, it's probably a good time to ask or save it for the end. And then after that, I'll talk about the C# 8 stuff, which you've probably heard a whole bunch of times already. Cool. All right, so let's dig into the stuff in C# 8. And I sort of think of this in its 4 major features, and also how those features can also be reflected in Kotlin. It's stuff that Kotlin has actually had for quite a while. So we looked at nullable reference types in Kotlin, and this is actually a behavior you can't turn off, where in C# 8, it's something you'll be able to explicitly add. And we get the difference between now our string has a question mark next to it to denote it as a nullable reference type. And we have that same sort of like automatic behavior and type checking and everything else that says, hey, you tried to access something that's nullable, you either need to propagate it with null or you need to dangerously set it with a bang. So the biggest difference, as you'll probably still notice, is that on the C# side for nullable types, we still don't have to explicitly instantiate it as null, because the default of a nullable type is null. C# smart enough to do that. That's why I actually really prefer the way C# does it. However, if we do take off one of those question marks for something like name, we do have to instantiate that with a name in the C# side on the right side of the equation. The next one is ranges, which I don't know if I've actually had like a real need for it, but it's sort of like a neat thing to have that other languages have also had for a while. So it's, in this case, I'm showing like the most basic example of a range, where I'm defining a range as 1 to 4 in terms of positioning. So instead of looping over every dog that's sent down to me, I'm saying give me from position 1 to position 4, and then also write their names in the console. But obviously I'm not checking like, oh, is the list of dogs not null, and does it also like have at least 4 available? I don't care about that right now. Kotlin has the same thing, but this is another thing where C# when they implemented it was like, oh, this is a nice little shortcut to add. So on the right side in Kotlin, you'll notice that we have the ability to assign a range as a variable. You can also do that in C# where range is a type, and we can pass it around. But I did want to show off where C# is a little bit more clever, where on the right side we don't have that accessor with a range. So we can't just take a list and say, give me 1 to 4, like we can in C#, but we can still define it as a type, pass it around, and do all that. But instead we just call like the sublist, and it's still clean. But I think this is like the first time the C# side got to like fewer lines of code. Also because we just have the obnoxious same line brackets, which I still internally debate so often. We also were introduced to default interface implementations. So I know some of you guys probably already went to all the C# 8 talks, and I think one of them at least talked about this quite a bit. But if you remember our original interface conversation with comparing it in C# to Kotlin, the left side was only those 2 definitions in the contract rather than an actual implementation. This time around, these look a lot more similar, where we actually are able to implement adopt dogs. It has to be explicitly public in iAdoption service, where we sort of get the nice default public on the right. But other than that, it's still basically the same. Other than little syntactical things, we now have the same capability of default interface implementations that we've had in Kotlin for the whole time. And Kotlin's just had it because Java's had default interface implementations for like ever. It's probably the only thing Java had over C#, which is also even just debated because people are like, well, no, why would I use an abstract class? I'll just make an interface and just have interfaces that I just don't actually use as an interface. And I don't know, I like it. I'll probably use it. This one is my favorite, and it's something I feel like people haven't really talked about enough. People are all about the nullable reference type and how your code's going to be cleaner and it's going to be safer. Throw away the null reference exception or the null pointer exception in the Kotlin and Java world. But this one, I feel like I can like actually really use, and I'll try to sort of like visualize what I thought about when I started putting together this slide earlier today. I'll go through the code first. So we have this concept of an async enumerable, and this is what is giving us the ability to stream things from that enumerable. So in that method, we're returning an async enumerable of type string, given a list of dogs, and we're looping over those dogs and saying, pause for a bit, then yield the return of that name of the dog. So I personally didn't use yield a whole lot back when I was writing a bunch of C#7, but it's basically saying I'm building an enumerable, throw this one in there, right? So every time we hit this, we're actually adding something to that enumerable. And down below, when we're running it, we can just loop over that just like we would with any sort of for each loop. But instead, this is going to hit that console.write line every 200 milliseconds with that name. So it sounds like, why would I use that? I just like batch load stuff, and I don't really care. But the way I sort of thought about it from like a mobile perspective is a lot of the way the paradigm works right now is you're loading a list of data. You're going to go grab like a chunk of like 10 things, load it into a list, and carry on. Well, this sort of gives us the ability to like asynchronous load one thing at a time, especially if you're interfacing with something like an API that doesn't have like a bulk with pagination capabilities in the API to say like skip this many, take this many. Instead, I can just go like, give me the one by this ID, then this ID, then this ID. And instead of just saying task.delay and return the name, I can say, go make an HTTP request, make that async, go give me the result of that, and then pipe that back down and then loop over that. So I don't know, I thought it was really cool, and I feel like not enough people are talking about it. This is something where, again, we've got way more lines of code in Kotlin to do it, but it's possible. And this is in some of the experimental things of Kotlin. So while we're talking about the future of C# with C#8, this is actually sort of like the future of Kotlin, which I think is planned to be fully released in 1.4. So let me just break this down for you from the top down. We have an async getName, which is an async method. You actually can see the async keyword, which we're getting a little bit into sort of the new coroutine stuff, so I won't get into too much detail. But the same thing, we're just getting the name of a dog, delay it, then return it. Then we have the actual get of all the names, right? So we have the ability to take in a list of dogs, but what we're returning is actually a list of deferred of string, a nullable string. So that deferred type is what allows us to actually await the individual result of it. So all we're doing is calling an array mapper map to get the async name. Then in the actual running block, which again is fired in a coroutine, we're able to say, give me the names, and then loop over them and await the individual result of it. So getting the async names gives me the whole list of the deferred, and it's just going to continue to run that. And then I'm going to await the result of each individual piece, which is pretty cool, but it's obviously a little bit more involved, and we're actually doing it with sort of like the more functional style where we're defining it at the coroutine scope rather than doing it in an object. But I thought it was a pretty cool example. Any questions about sort of like those really, really new, really cool C#8 features, or how you can actually implement the same sort of thing in Kotlin? So in this case, it's going to execute it one at a time. So in this async name, all we're saying is that we're mapping the list of dogs to basically the list of this method, this async function in the coroutine. So this is an entire function, and we're actually mapping the dogs to that list of that function, and then we're able to await it one at a time. So you can think of like this list of deferred string is like a list of a function that returns me a string asynchronously. And so then we're able to loop over that list just like we would any other, and then we just say .await, and we'll await for the individual result of each one in the list. Any other questions? Cool. I think this is like the last major section, but talking about now the future of Kotlin. There's a lot going on. It's open source, so it's not just JetBrains working on it, although they have a dedicated team of some of the best developers in the world designing this language. It's also open source and allowing people to actually make pull requests to the compilers. So the JavaScript compiler, I believe, actually came from an initial concept from an open source community member. So if you're interested in actually getting involved in a community that's like very open to the concept of people hopping in, which also has great documentation, it's sort of the best place to be. But let's talk about them one by one. So more coroutine stuff. It's brand new, like 1.3 just released. That's when they were finally like, coroutines are ready. But like I just said, with that sort of streaming asynchronously stuff and that deferred type and being able to await that, that's still experimental. I wouldn't be using that in production. So that sort of stuff is going to continue to be developed, continue to be tested against all the different platforms. Also, the native compiler, it's currently in beta, which is also the 1.3 release pushed it to beta. They're basically just trying to get it ready for a production environment. And then continued IDE enhancements. This is mostly in regards to the multi-platform stuff. So if you've ever run .NET with multi-platform, so something like Xamarin, or even just like talking to a ASP.NET web app and then like a console app, and you're abstracting your code into like different projects that it then references, Kotlin's trying to do more of this because it has to use a different compiler for each of those different platforms. So being able to support code that's shared between JavaScript and Java and native and iOS with all of its extra tooling, they want to be able to build it into the tooling a bit better to handle that. So this is also in preview right now. They're trying to push people to do it a bit more. Same thing with C#. If you're already writing C# apps and you already have a whole bunch of business logic, just throw a mobile app on it and run with it. They're trying to promote that sort of behavior as well. So that's it. I'll get into the summary, but what I hope you can take away from this is that both these languages are super cool. And that you can take the knowledge of the style that you develop in C# and apply it to places where it can't support it right now. Build stuff on the JVM. If you're in consulting and someone comes to you and like, oh yeah, we got this legacy Java system and I need you to come in and help us work on it, and you're like, I'm a .NET dev, that kind of sucks. It doesn't have to suck anymore. Kotlin's pretty cool. Or if you just hate JavaScript so much and you don't feel like touching TypeScript, which is I'd put it over here as my like third favorite language. You can also write Kotlin there as well and share that across your different platforms. So I also want to emphasize that we like barely scratched the surface with this language in the platforms. We didn't really talk about anything about the functional side because we're comparing it to C#. I definitely encourage people to look into that a bit more. We didn't talk about any real design patterns other than here's object-oriented programming. But we didn't talk about how you can implement things like dependency injection, proper inversion of control with other practices. We didn't get into much of the actual deeper language features. We talked about the basics and we talked about coroutines, which is probably about as far as we could go. We also didn't talk about any of the cool tooling that the Kotlin team has built, like Ktor, and how that's actually implemented and why it's so much better and faster than Spring, and arguably in certain cases than .NET Core, or Enko, which is their whole other suite of tools that can do just about anything for you, including like data syncing between your coroutines and stuff like that. We didn't get into how to build things with native or with JavaScript or into all the other cool Android tools. So I definitely encourage you to sort of do that research. If you've found interest in the language itself, it's definitely worth seeing what you can really do with it because it's pretty crazy. So I have some resources here. That's the actual compiler set for Kotlin. That's a spec and compiler and everything else that's open source by JetBrains. There is also a Kotlin organization which has like the extra toolings like Ktor and Enko and stuff like that. All the examples that you saw in the slides are also available on my GitHub, including what my original talk was, which also included a basic Android app with Kotlin to a Xamarin.Android app. That's also up there. We just don't have time to continue to go over the sort of basics. I wanted to introduce the C# 8 concepts because I felt that was more interesting. Also, check out my Pluralsight course on it. If you're interested in doing Kotlin in an actual implementation, I have this Building Android Apps with Kotlin Getting Started. It's interesting. We go through the process of building a real-world app from scratch without any assumption of Kotlin knowledge at all. So we do things like execute requests to a third-party API and then actually sync that down to a local database, handle navigation in a more complex app between different types and sort of the different layouts and structures you can use in Android. And then, like I said at the beginning, check out my blog series on this and all my other Kotlin and C# stuff. And then I'll put these slides up on Twitter at the end. So be sure to follow me, Suave_pirate there. And thank you. Minutes left if anyone does have questions or anything or just wants to talk.